Welcome. So what do you need to know to be able to complete this course by graphing a quadratic in vertex form? So the first thing I say is we need to know exactly what is vertex form. Well, vertex form is y equals a times x minus h squared plus k. All right. The next thing that we're going to need to know is understanding, what is the vertex from there, or where exactly is the vertex. Remember, when we are graphing a parabola, all right, either the lowest or the highest point in that parabola is what we call the vertex. Okay, so that's going to be our lowest or highest point of the parabola, and that's going to be a vertex. And the equation for the vertex is h comma k. And one thing again, notice in the formula it's x opposite of h plus k. The next thing is understanding translations. We have talked about, in geometry, we dealt with reflections, rotations, and translations are kind of like slides. So think about it. If the main important thing to understand is, I can take this graph and I can shift it up, shift it to the left, shift it down, shift it right. I can do a whole bunch of different translations to the problem. And we're going to be using a lot of translations. And basically what we're going to be doing is taking the vertex, because it's in the equation. It's very easy to see. And what we're going to do is we're going to be translating that vertex to different positions based on where the new vertex is going to be. So a lot of times what we use is, and I'll get into as far as in paragraph how to do that. The next thing is end behavior. Understanding that when a is less than 0, the graph opens down. When a is greater than 0, the graph opens up. And that's very important because we're going to be taking the paragraph, applying different transformations. And we need to know, is the graph going to open up or is it going to open down? So understanding the value of a is going to become very important. The next thing is understanding the parent graph. So let's look at the parent graph of a quadratic. OK, so here is the parent graph of a quadratic. There's a couple points, 1, 1, and 2, 4. All right. Now, this is y equals x squared. That means I am not stretching or condensing this graph at all. My a is 1. So I have an axis symmetry on the y-axis that the graph reflects about. So I'm not going to write these other points, but this is -1, 1, and this is -2, 4. But it's very important that you automatically know these points. So if I don't have an a, or if a is, if there's no value of a as far as an absolute value that is other than 1, then these points are going to stay, and they're in their relationship to the vertex. It's going to be over 1, up 1, over 2, up 4. That relationship is going to stay intact for all transformations unless the absolute value of a is going to be greater than or less than 1. So when we're applying our transformations, what I was kind of getting to is you should know that that regular graph starts here, right? And if I now bring in y equals negative x minus 3 squared plus 1, what this tells us is now the vertex is at 3, 1, right? Because it's x opposite of h. So now I went over 1, 2, 3, up 1. So now my vertex has been translated over to this point. I also understand that the end behavior is going to tell me to open down. So it's going to look something like this. And then remember the relationship between the points, over 1, up 1. But now the graph is going down. So it's over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4. All right? The last thing is evaluating points, because sometimes that number is not going to be even. So therefore, it's not going to be over 1, down 1, right? Because now my a, the absolute value of my a is larger than 1. So to figure out what the next points would be, I have to be able to evaluate. And all I can simply do is creating a table. And we know that our vertex is at 3, 1. So what I need to do is, again, use my axis symmetry, pick points to the left or to the right, and evaluate for them. So let's pick 0, right? So if I wanted to evaluate for 0, I'd have y equals -3 times 0 or 0 minus 3 squared plus 9. So when I'm saying evaluate, I'm saying pick points either to the left or right of the axis of symmetry and plug them in for x. So I have y equals, this becomes negative 3 times negative 3 squared plus 9. Negative 3 squared is 9. 9 times negative 3 equals negative 27 plus 9. Y equals negative 20. And then you'd want to evaluate for at least another point to help you connect the graph. But that is going to be evaluating points, and those are going to be the main important thing that we need to know as we work through this course. Thanks.